Good morning, Tahmina Khan is here in TKMaths is fun. In today's video, which is video number 2.2 on lessons of mechanics, A-level mathematics. In video 2.1, we have covered distance and displacement, speed, velocity and average speed. Now in this video, we will cover uniform acceleration formula and few questions on it. You will find the link of all the other videos I have made in the description below. So this is the series of complete lessons on A-level mathematics M1. So let's start. What is an acceleration? So acceleration is used to measure how quickly velocity is changing. And we are talking about here for an object which is moving with the constant acceleration. So acceleration is equals to change in velocity divided by time taken. And acceleration is represented by A. Now change in velocity, V minus U mean final velocity minus initial velocity. So final velocity is usually represented by V and initial velocity is represented by U. And acceleration unit is meter per second square, kilometer per hour square, mostly meter per second square. So where U, V and A are all measured in the same direction, we have already discussed all this in the previous video where we were discussing, we will discuss it in free fall. We have not done it yet. So you will see the description or the explanation on this in the video free fall, which will be next video. So here are the symbols used for initial velocity, final velocity, acceleration, displacement and time. So you will understand when we use these symbols, these letters rather. So uniform acceleration formulae, there are certain formulae which are known as SWOT equations, right? And here they are. V is equals to U plus AT, S is equals to half U plus V times T, S is equals to UT plus half AT square, S is equals to Vt minus half AT square, and V square is equals to U square plus 2S. So these are the equations we use when we solve constant acceleration formula. So let's very quickly, how do we get these formulae? It's not a part of the syllabus, but just for the understanding concept. So within 2 minutes we will cover this. So let's just start with the basic formula of acceleration, which is A is equals to B minus U divided by T. So how you will get the first one from here? Absolutely right, it is just the manipulation of the formula. So V is equals to U plus AT. I'm calling it equation 1. Now we will try to get next equation, which is S is equals to half U plus Vt. So what comes in your mind? How you will do that? So 30 seconds yours, you can think. This part is a little tricky for students at times, so let me show you here now. Because we are talking about here uniform acceleration. So if you have to find out the average velocity, you can take the average of the final and initial velocity, right? So I'm applying the concept of average here, basic mathematical concept. But at the same time, we know average velocity is displacement over time. So if you equate displacement over time here, so it will be U plus Vt, and then manipulate it, you will get S is equals to half U plus Vt, right? Now comes the third one, half S is equals to Ut plus half AT square. I'm calling it equation 2. So equation 1 you have seen here, which is this one, equation 1. This is 2. Now we have to get S is equals to Ut plus half AT square. Absolutely right. You have to make use of these two by substitution and you will get the third one. So what happened here? This value of V, if you substitute here, which I have done here, you can see in this place, and then simply manipulate it, it will become S is equals to Ut plus half AT square. So basically from equation 1 we have taken the value of v and substituted in equation 2 and got it. But at the same time, if you make t a subject from equation 1, right? If you make t a subject, you will get this. T is equals to v minus u divided by t. And then substitute it here. It is s is equals to u plus v t over 2. So here in place of t, if you plug in this value, you will get this equation. So this is how we get one equation from the other by manipulating, by applying the concept. So this was just for your understanding. It's not required in the syllabus as such to prove or anything. So let's see the application of these constant acceleration formulae in the word problem now. Okay, if you want to put the video on pause and want to try it yourself, you can do that. Otherwise, I'm explaining it here. Okay, a go-kart travels down a slope of length 70 meters. So let's keep writing here the information we have. So s is equals to 70 meter. It is given a push and start moving at an initial velocity of this. So initial velocity we represent by u, right? And it is going by the acceleration of 2 meters per second. So a is equals to 2. Always write down the information given in the question first of all in the correct symbols. Then it will be easy to apply it in the formula. Find its velocity at the bottom of the slope. So suppose slope was like this something. So it started or pushed from here, and now you have to find out the velocity here. So this is what you have to find out. This is what is given. The displacement is 70 meter and acceleration is this. So which SWOT equation you will use here? You have to see what information is given. Sometimes two can be used. So you see which is easy for you to use. So I am right now using the last one, which is v square is equals to u square plus 2as. After that, you just have to plug in the values and use the calculator. So let me also use the calculator. So v is equals to, just a minute. Okay, so I got here plus minus 17 because it was a square. So it is understood that velocity will be positive. It has to be greater than 3 as it is coming down and it is speeding up, because otherwise velocity can be negative also. But in this case, the velocity is 17 meters per second. Now let's do part B. Part B is find the time taken for go-kart to reach. So now the same situation, but you have to find out how long it took. So which one do you think is right? I can use here this also, but I would like to use this. It's easy. V is equals to u plus at, because now I have v. So for part B, I will use v is equals to u plus at. So v is 17, u was 3 given, v you have just calculated, right? And a is 2, and t you have to calculate. So now if you calculate it, what it will be? Let's do it. 17 minus 3 divided by 2. So it will be t is equals to 7 seconds, right? Okay. So now I will explain one more and then I will give you one for you to do. But this one also you can do yourself if you want to try. So you can put the video on pause and try it. Else I am solving it here. Okay, so part A. Let's see what information is given to us first. A cyclist travels downhill. Again, it is downhill, uniformly accelerating. So acceleration is given here, 1.5 meter per second square. His initial velocity at the top is 3 meter per second. How far he travels in 8 seconds. So distance you have to calculate. So what comes in your mind out of these SWOT equations? Which one you can use? I can use this one. S is equals to ut plus half at square. S is equals to ut plus half at square. And please always write down the formula first and then show the substitution, right? There is 1 mark for this in the marking scheme, so once you know everything, why not get the full marks? So let's take the calculator. Give me a second. Let me calculate. Okay, so it is 72 meter. Okay, so part B, how far he travels before reaching a velocity of 7 meter per second. So in 8 seconds, this is the velocity. Now, when the velocity was 7 meter per second, it is started with 3. So maybe somewhere here, the velocity is 7 meter per second. So what was the distance at that time? This is the question. So now, what information I can use here? For part B, I can say U is 3, same thing given to me. A is 1.5 given to me. Final velocity is also given to me. It would be 7, and this I have to calculate. So which one you should use? Which sort equation? Okay, this one. So V square is equals to U square plus 2AS, right? After that, I think it is very simple. You just have to plug in the values. Now give me a second. Let me calculate it. Just a minute. One more. If I write here to avoid any confusion, 7 7s are 49, 3 3s are 9. Okay. Now let me use calculator. So S is equals to 13 1/3 meter, right? So this is my distance covered. Okay. So one thing which I have not told you here, when we use the word retardation, right, it means acceleration speed is changing, right? So if somebody say A is equals to minus 2 meter per second, it means retardation is 2 meter per second. So if you use A, you can write minus 2, but if you use the word retardation, then you will use 2 meter per second. Okay, clear? Because in the next question which I am giving you, you will try first, so you have to be careful. So here is a test for your understanding. You can put the video on pause and solve it, because I am going to show you the solution so that the length of the video remains small. Okay. Even then I'll give you 15 seconds. So I hope you understood the question. Horizontal sheet of ice. So maybe this is a sheet of ice, right? So, this is the sheet of ice. When something enters from here, it will start slowing down because it is ice, right? And then gradually, depending on the speed here, it may pass through or it may stop here, anywhere. Okay. So, first part of the question is saying the speed at A is 14 meter per second, and at B, which is inside this sledge, of course, A is also anywhere. Okay, I don't know. I'm just making it that it was when it was entering. Otherwise, it could be here. They're just saying it is a line across horizontal straight sheet. So let's see here. For first part, this is the information given to me. Suppose this is B. So this distance is given to me is 30 meter. I have to find out the acceleration. So which formula you will use? Absolutely right. S is equals to ut plus half at square, and then you will get your acceleration, which is minus 1.6, or you can say retardation is 1.6 meter per second square. Second part is saying find the velocity here. At this point, what is the velocity? Now which formula you will use? You can use V is equals to U plus AT, right? Or any other also? V square is equals to U square plus 2AS, right? So now you know the velocity at B also. You have already calculated. I'm just showing you my working so that you can tally with your working. And last part is how long after passing A the stone comes to rest. So suppose the stone comes to rest at this point. So again the information given to you is U40, V0, A minus 1.6. So you have to use which formula of SWOT you will use to get the time. So it is 8.75 seconds after passing the point A, the particle will come to rest. So with this, we have completed these concepts so far, right? And links are given in the previous video. So now, in the next video, we will talk about free fall. So gradually we are completing lesson 2 on M1. So thank you very much for watching. Please share it with your friends and press like and subscribe button. Thank you. Take care.